Sometimes data tells story that looks obvious until you look little closer at it. You launch new app feature and average user engagement goes up. You try new teaching method and average score increases. At first glance, it feels like success. It feels convincing. But here's the uncomfortable truth. Averages can be misleading. That increase you are seeing might be real, but it might just be random chance. So, how do we tell difference? That's exactly what t-test is designed to answer. Welcome back to Shital's Data Desk. I'm Shital, and in this video, we are going to deeply understand t-test with intuition, visuals, and real-world examples. In this video, we are going to cover why averages alone are not enough, what is t-test, what is t-statistics, types of t-test, role of sample size, assumptions of t-test, common misconceptions, and when not to use t-test. To understand why we even need t-test, we first need to talk about something we rely on all the time: averages. Averages feel simple, they feel precise. But in statistics, averages alone can be misleading. Imagine this: you test two versions of website. Version A, average time spent equals to 4.8 minutes, and version B, average time spent is 5.1 minutes. At first glance, version B looks better. But pause for a moment. Is version B truly better? Or could this difference simply be due to random variation in users? Now imagine you run same experiment again. This time you get version A is 5 minutes and version B is 4.9 minutes. Same website, same kind of users, different averages. So, real question is not are averages different? Real question is this difference statistically meaningful, or is it just randomness playing tricks on us? Statistics never assumes differences are real by default. It tests them. And tool we use to test whether difference between two averages is real or just random is called t-test. So now we understand why averages alone are not enough. The next logical question is, how do we actually test whether difference is real or just noise? That's where t-test comes in. At its core, t-test is statistical method used to compare averages and determine whether difference between them is statistically significant or likely due to random chance. In simple words, t-test helps us answer questions like, is difference observed meaningful, or could it have happened just because sampling randomness? T-test does not just look at difference between two averages. It also considers how much variation exists in data and how large sample is, because small difference can be important or completely meaningless depending on how noisy data is. To understand how t-test does this, we need to look at what information it actually uses. Every t-test is built on three simple components. First, difference in means, meaning how far apart are averages. Second, variation in data, meaning are values tightly clustered or widely spread out. Third, sample size, meaning are we looking at 10 observations or 1000? When these three pieces come together, t-test turns them into single number. Using these three pieces, t-test calculates something called t-statistics. This number tells us how large difference is relative to noise in data. Large t statistics means difference is unlikely to be random. Small t statistics means difference could easily be due to chance. Let's understand this idea intuitively. Here's simple way to build intuition. Think of it this way. If two groups have very similar averages, lots of variabilities and small sample size, then small differences are not surprising. But if two groups have clearly different averages, low variability and enough data, then the difference starts to look real. T-test formalizes this intuition and turns it into mathematical decision rule. So, once t-test does its calculation, what do we actually conclude from it? After running t-test, we don't say group A is definitely better than group B. Instead, we say based on data, observed difference is statistically significant or not significant. at a chosen confidence level. In other words, t-test helps us separate signal from noise. If you remember just one thing from this section, remember this. T-test doesn't ask whether averages are different. It asks whether they are different enough to matter. So now we know why averages alone are not enough. And we know that t-test helps us decide whether difference is real or just noise. But how does t-test actually make that decision? It does it using one key number, t-statistic. T-statistic measures how far apart two averages are relative to how much natural variation exists in data. T-statistic asks, is the difference between these averages large compared to random noise? Let's understand idea behind t-test in simple language. Imagine two groups. Group A's average is 75 and group B's average is 78. Difference is 3 points. Now ask yourself, is difference of 3 points big or small? Answer depends on variability. If score barely vary, 3-point difference is huge. If score vary wildly, 3-point difference is nothing. T-statistic captures this exact idea. T-test asks simple question. Is the difference we are seeing bigger than what we would expect from random chance? And to answer that question quantitatively, statistics uses one key number. That number is called T-statistic. T-statistic is simply a comparison. It compares two things side by side. First, difference between group mean, and second, variability or noise in data. In simple terms, it measures signal versus noise. In other words, it asks how many standard errors apart are these two averages. If the difference is small compared to natural variation, t-statistic will be small. If difference is large compared to variation, t-statistic will be large. Now that we know what goes into t-statistic, next question is obvious. How do we interpret its value? What does small and large t-statistic mean? Small t-value means difference is small compared to noise, likely due to random chance. And large t-value means difference is large compared to noise, unlikely to be random, evidence of real effect. So, bigger the absolute value of t-statistic, stronger the evidence against idea of just chance. But there's one more subtle detail we haven't talked about it. T-statistic doesn't just tell us how large difference is, it also tells us which direction difference goes. Positive T-statistic means first group has higher average than second. For example, group A mean is greater than group B mean. Negative T-statistic means opposite. Size tells us how strong evidence is. Sign tells us which group is higher. So now we understand what t-statistic measures, how to interpret its size, and what its direction tells us. But there's still one crucial question left. Is this t-value large enough to be considered statistically significant? Once we compute t-statistics, we compare it to the t-distribution. This comparison gives us p-value, which answers very specific question. If there were actually no real difference, how likely is it to see t-value this extreme? If p-value is small, it means this result would be very unlikely by random chance. If p-value is large, it means observed difference is quite plausible due to randomness. In short, small p-value means evidence against chance, and large p-value means difference could easily be random. T-statistic is not magic. It is simply standardized measure of difference that accounts for sample size, variability, and randomness. This is why t-test is so powerful. It doesn't just ask are averages different, it asks is this difference meaningful? So now we understand full logic of t-test. We start with averages. We quantify uncertainty. We compute t-statistic and we use p-value to make decision. Final question is which t-test should we use? Because not all comparisons are same. Sometimes we compare to independent groups. Sometimes we compare same group before and after. And sometimes we compare sample to a known value. Let's look at different types of t-test and when each one is appropriate. Let's start with simplest one. First, one sample t-test. One sample t-test is used when you have one group and you want to compare its average to a known or fixed value. For example, Is the average exam score different from 70? Is the average delivery time different from promised 30 minutes? Is the average battery life different from advertised value? Here, there is no second group. You are comparing your sample mean versus known benchmark. Question becomes, is my sample meaningfully different from this reference value? Or could the difference be due to random sampling? That's exactly what one sample t-test answers. Now, let's move to most commonly used t-test, independent two-sample t-test. Independent t-test is used when you have two separate groups and observation in one group have nothing to do with another group. For example, website version A versus version B, teaching method A versus teaching method B, control group versus treatment group. Each observation belongs to only one group. Here t-test compares difference between two group means relative to variability within each group. Now key question is, are these two group averages genuinely different or could the observed gap be explained by random variation? T-test is everywhere. A-B testing, marketing experiments, clinical studies, business analytics. When people casually say t-test, they usually mean this one. Now, let's look at case where data is connected, that is paired t-test. Paired t-test is used when same objects are measured twice or observations come in natural pairs. For example, before and after training program, blood pressure before and after medication, test course of same student before and after coaching, productivity of employees before and after new tool. Here, we are not comparing two independent groups. Instead, we are comparing each subject to themselves. Paired t-test works by calculating difference for each pair and then testing whether average difference is meaningful. This makes paired t-test very powerful because it removes lot of individual variability. So now we understand what t-test is and which type to use depending on situation. But there's one factor that quietly influences every t-test result, and that is sample size. Let's talk about why sample size matters so much. Sample size plays huge role in how reliable our results are. As sample size increases, our estimates become more stable. With small sample, averages fluctuates a lot. Random noise has more influence. Uncertainty is high. With large sample, averages stabilize. Random variation cancels out. Uncertainty decreases. This directly affects t-test. When sample size is small, t-test is more cautious. It requires stronger evidence to declare difference significant. As sample size grows, t-test becomes more sensitive and precise. So remember, small samples equals to more uncertainty and large samples equals to more confidence. This is why statistics always rewards more data. So, sample size clearly affects how reliable our t-test results are. But even with good sample size, t-test doesn't work blindly. Before trusting result of any t-test, we need to pause and ask one question. Are we allowed to use t-test in the first place? Like any statistical tool, t-test comes with assumptions. It is powerful, but only when used correctly. Main assumptions are: first, independence. Each observation should be independent of the other. One person's result should not influence another's. Second, normality. Data, or at least sample mean, should be approximately normally distributed. Thanks to the central limit theorem, this becomes less of an issue with larger samples. Third, equal variance, specifically for independent t-test. Spread of data in both groups should be similar. If not, we use slightly adjusted version called Wells t-test. Important point, t-test is fairly robust. Minor violations generally don't break it, but ignoring assumptions completely. That can lead to misleading conclusions. These assumptions might sound technical, but they matter more than people realize. And when they are misunderstood or ignored, they lead to some very common mistakes. So, let's clear up few misconceptions about t-test. T-tests are widely used, which also means they are widely misunderstood. Let's clear up some of most common misconceptions people have about t-test. First, significant t-test means difference is large. No, it only means difference is unlikely to be due to chance. Even small differences can be statistically significant with large samples. Second, non-significant result means there is no difference. Not necessarily. It may simply mean sample size was too small, data was too noisy, or test lacked power. Third, p-value tells us how important result is. Wrong. P-values measures evidence against chance, not real world impact. Statistics answers, is this difference statistically reliable? Not, is this difference meaningful? That interpretation is your job. Good statistician doesn't just know how to use t-test, they also know when not to use it. So, let's look at situations where t-test is wrong tool. T-test is extremely useful, but it is not universal. You should not use t-test when you are comparing more than two groups. Data is extremely skewed with strong outliers. Observations are not independent. You are analyzing proportions or categorical outcomes. Statistics is about choosing right tool, not forcing one tool everywhere. Knowing when not to use t-test is just as important as knowing how to use it. So, let's step back and summarize everything we have learned. Averages alone are not enough. T-test compares signal to noise. T-statistics measures how big difference is relative to variability. Sample size strongly affects confidence. Assumptions matter. Statistical significance is not same as practical importance. T-test isn't about proving differences. It is about testing whether difference is real or just random noise. Once you understand that, statistics stops feeling intimidating and starts feeling logical. If this video helped you understand statistics more clearly, please like, subscribe and share it with someone learning data or analytics. This is Shital's Data Desk, where we turn uncertainty into understanding. Thanks for watching and I will see you in next video.